let's take a look at some common web applications attacks against web applications running on web servers. And this is typically accessed across the web. So in traditional web applications, we've got a server, which could be on a Windows, could be Linux, and it pretty much hosts a bunch of stuff. It could host a sales platform, could host maybe a login function. And this is traditionally a platform of such, and then a user or a contractor or maybe external third parties log into this web server, and we can perform functions such as maybe accessing our superannuation account information or access our banking information or providing team collaboration platforms, and the list goes on, right? So these are, in this video, we're going to cover a couple of web application attacks against, web applications and specifically web servers and the likes of those kinds of attacks. So the very first vulnerability that I want to talk about is our directory traversal. Directory traversal, in a nutshell, is basically moving or having the ability to move around directories. Now, this vulnerability, let me just finish writing that. Okay, so the idea behind directory traversal in a nutshell is basically that unauthorized access to move within different file structures of a web application server. So let's just say that we've got a web application server just here, and then we've got a couple of directory structures. Let's say at the root, we've got www, and then we've got something like data, and then we've got images, and then maybe we have, backups, and maybe we have, something else. And I've got a question for you. If I'm in the images directory, should I have the ability to access the data directory, or should I access the root of that directory? Or can we move into the actual operating system of that web server or the actual server itself and then access or move around between those different directories through maybe the root folder or maybe the home directory, and the list goes on. So if I hear you screaming out, no, we shouldn't have access, well, you're absolutely right. And that's to prevent unauthorized access between our directory structures. And with directory traversal, it's basically a vulnerability that allows us to directory traverse. So let's just take a look at this URL here. And this is a common directory traversal kind of attack. Now, if I add some functions here, I'll just go etc password or etc shadow. Now, I'll just talk about these in just a moment. So the first thing that I kind of notice when I look at this URL is these ... And this just basically says, if I'm in the images directory and I go ... I can then move into the data directory. And again, if I go ... I can then move into the www directory. So hence what moving around the directories is all about. So this is the first thing that I kind of see here is, well, this is potentially on a Linux machine. And basically what it's saying is, well, there's a URL right here, which is url.com. And then we are looking for a specific file name. Now, we don't know what that file name is, but the file name that we're looking for is ... So should we enter enough of these ... in, well, we can start pulling maybe data out of the actual operating system. Take exhibit A, which is our etc password and our etc shadow, which is a highly, highly common directory traversal kind of attacks. And the idea behind these two are, let me just change my pen here. The password, I just do password with a D, not just a W. And the idea behind the actual password function is basically saying, well, these are files that are containing users on the actual system or on that host. And traditionally, we could see things like the username, maybe the ID of the account, maybe the home directory information, and basically any sort of details or information on the users of this host. So we won't be able to see anything like the hashes or passwords, and that's where our etc shadow comes into play. And if we can pull the data out of the etc shadow, we would have a list of the potential usernames along with the hashes. So again, that's the directory traversal in a nutshell. And the next sort of question that I've got is, well, how do we prevent this? And I'm going to change the color of the pen here because it looks like the green and the red do not mix. And I'm just going to go prevention. And the very first thing when we talk about prevention is just to ensure that I would say don't allow the user input for that file access, meaning we don't want to allow users to enter files that they want to see. So don't allow files to be seen. And this is basically saying, well, if we have to, instead of allowing the users to enter that they want to see a specific file or a specific part of that URL, well, we don't want to do that. We want to hard code that list, and we can give the users a bunch of options. That way they can have a drop-down menu that says you can access X, Y, Z, and you can specify the list of those drop-down options where they can click, where it won't display the results of that in the actual URL function, which we can go away and edit that. And then we can put in something like this, which says file name, .. all the way into the Etsy directory, again, giving us that unauthorized access. So we want to hard code or sanitize, again, that user control where we can hard code what the users see, not giving them something that they shouldn't be able to see. And then obviously that ties into that controls mechanism, right? So we want to make sure that not allowing the user input of that data. So if we do need to do that, then we want to validate the user inputs to ensure that they are putting information that they have access to, or that there's permissions that are associated with what they're trying to pull down, or again, have access to view the content of that directory. So that's directory traversal in a nutshell. Moving on to the next topic of conversation is cross-site scripting. And cross-site scripting is and has been around for many years. And the idea behind this is basically putting in malicious code to maybe search functions, but putting in malicious code to a web server. And the idea behind this is traditionally common around blog posts or maybe search functions. And you can put in nefarious sort of commands. Anytime we go to a blog post, there may be like a search function here, and then we can put in a bunch of code that has the ability to do something, whether it's code execute something or maybe upload a file to that web server, which will cause a bunch of different things to sort of happen. So again, if that data is not filtered, then the scripts end up running, or and then something sort of kinds of happens. So again, the attacker can then define a laundry list of different things that they want to happen when they're inserting cross-site scripting. So there's 3 different forms of cross-site scripting. So I'm just going to say a big 3 here. I'm not going to cover them in this video, but just so you know that they exist, and you can obviously do some further reading, and in a different video, we can cover the details behind these in a little bit more detail. This is just a bit conceptual and just as an overview across a couple of different web application attacks. So first one is DOM-based, then we have reflective, and then there's our server side. And server side is probably the most dangerous. And this is basically saying that anytime we go to a web function, a user, if it's server side, it will basically affect the server itself. So if we put nefarious code into that web server, that will then impact any other users who, if this is a user within the organization, or maybe someone that's actually using that function, and then they browse over to the blog function, well, chances are that code, or that code that person has put in that server side, or susceptible to server side cross-site scripting, well, then that's going to then be able to run on that user's machine or that web browser. So just be mindful that this is basically a piece of script that goes on there, and then it's infected in specifically that web server's functionality. So anyone that has the ability to then view that web page or visits that page, well, then it'll run in their actual browser session. So that's kind of cross-site scripting in a sort of overview session. What are some of the prevention mechanisms that we can implement for cross-site scripting? And the very first thing that I would say is filter the user input. Now, we don't want to be adding in nefarious codes, or if we can put in a Python code, or if we can put in some bash scripting, we can then specify that making sure that code is not allowed to be input, or anything along the lines of special characters is used in the code and things like that. So we are able to filter out what's accepted opposed to those data entries that are being allowed. And anything not, well, then that's going to be denied and obviously not run. Moving on to our third area, which is cross-site request forgery. And cross-site request forgery has been around for a long time. Again, basically the idea behind XSRF is basically forging users, or basically requesting forgery that users are tricked into running code within that application that typically have open. So if we've got a, let's say we're on a PC here, we're on a machine of some sort, whatever that we're running, Windows, Linux, Apple, Mac, whatever. And the idea that is that if I launch an application, then I can request that, as the user that's running this application, I've logged in and we've got some sort of tokens that are running in the backend that validate our sessions and things like that. If this is a payroll platform, for example, and I've got the head of HR that's logged into this, payroll platform, well, the idea behind cross-site request forgery is that we can run that program within the actual payroll program, and then it can then go away and do maybe sending bank account information details out, or sending nefarious funds out to other accounts, and the list goes on, right? So it's basically running that code within the application. There's obviously a very long list of requirements with cross-site request forgery. One, we need to know the user accounts, we need to know the web application servers, and then from there, we can obviously, time those attacks against the messages. So that way, when the users might open that specific link and view that information, well, then we can use that session of the account or of that user to gain access to the application to obviously access other areas or do things within that certain application, sending off payments, sending off information, etc. And some common prevention mechanisms across cross-site request forgery, well, the very first thing is tokens. And this is along the idea that anytime a user logs into that web server, they are assigned a token. And that token has obviously a session expiry. Now, from there, that token is obviously randomized. There's a randomization process that happens. So it's randomized, it's a randomized value token essentially. And then we pass that token to the actual client of the server, which will then pass it every time we do activities within the application. So anytime I may, click, if this is a payroll platform and then I have to log in. So logging in may be passing that token to the server. So that's the token. If I have to process payments, well, then we have to send that token off to the client, to the server. So I'm just going to put server here. So anytime we do any sort of activity within the application, there's a token that sends the information back over to the server, and then it validates the certain controls and obviously the level of permissions that we have. So the token is part of that user's profile. So in cross-site scripting or in cross-site request forgery, typically what would happen is anytime an attacker would try to inject code into the application without the use of the token, is just going to deny it. So obviously that's a good thing, and that's one of the common ways to prevent cross-site request forgery. And finally, I've labeled this one as injection attacks, because injection attacks come in many different forms and different flavors and different protocols and versions. And typically, this is injecting code into the application through multiple areas, such as maybe user inputs or running commands with the codes. And some common ones we've got XML injection. We may have something like LDAP injection. And there's obviously different protocols that are running. We've got SQL injection, which is what I was going to name this, but I thought, look, there's different types of injection attacks. And the idea again behind this is, well, it was like a process injection, just while kind of thinking of that, right? So we can inject information into certain running processes of the operating system and service functions, etc. So processes are another one. And this is basically the idea behind injecting code into these different types of processes, which again run against that host. So some typical prevention mechanisms, well, the very first thing is filtering out user input, right? If we can filter what we can enter, well, then that's half the battle, right? So if we can hard code that we are only accepting 12 characters and nothing else. So that means in a bash script, if we're going to put in something that doesn't have just 12 characters and it's maybe a laundry list of code, well, then that's not going to run, right? So we're going to sanitize and obviously filter out those commands, the special characters, and filter out any sort of nefarious attacks or commands that could actually take place against these running protocols. I hope you've enjoyed this video. They're the 4 common web application attacks. As always, I'll see you in the next video, and I hope you've enjoyed this video. Thank you.